Good morning. Today we're going to be covering section 9.2. This is our last section. I know that you are so sad that this is going to be the last new thing that we have to learn in statistics. So what we're talking about today is once we've determined that there is some sort of linear relationship on a scatter plot, which is what we talked about in section 9.1, so if we have a value for r that's somewhere near 1 or negative 1, what we're going to do is we are going to go ahead and figure out the best equation for a line that relates these data points together. So there is a mathematical way to determine what the very best line is that relates these data points. And what we do is the line that we're going to be calculating is the line that minimizes the distance between every point and the line. Okay? And so in order to do that, we actually have a formula, and the formula that we use to determine this is actually uses the same information that we learned how to put on our table in section 9.1. So this formula down here, okay, has a couple of different parts to it because when you write the equation of the line is always y equals, and then in our other math classes we've written mx plus b. Well, in statistics, we don't use y equals mx plus b. Don't ask me why, I don't know. But instead of using y equals mx plus b, the equation that we end up using is going to be y equals a plus bx. Still an equation of a line. A still has to be filled in, b still has to be filled in, and x's and y will remain your letters. So in order to do that, we have to learn how to calculate the slope using our statistical data. And please pay attention in statistics. Again, don't ask me why, but B is the letter that we use for slope. Again, it's multiplying the letter x, so we know from our previous math experience that that has to be the slope. And then we have a formula to determine the y-intercept, which in statistics is letter A. Okay? So again, the information that we use to calculate these two values is the same information from the table that we learned to create in section 9.1. Okay, so when we are looking at the equation that we generate, there is one point that always falls on the best fit line. You're going to see the best fit line also referred to as the least squared line because it's minimizing the distance, squared distance between the points on your graph and the line that you're choosing as the best line. And there's always one point that has to be on there. So when you're graphing your line, this is really important because this is one of the points that you're going to use to graph that line very quickly and easily. Even if you have a terrible y-intercept and a terrible decimal number for your slope, you know that this point is on your line. It's going to help you graph your line. Okay, and that is the point x bar, comma, y bar. Okay, and what does x bar stand for? On a scatter plot, x bar is going to be the average of the x values, and y bar is going to be the average of the y values. And so this point, x bar, y bar, is always going to fall on our best fit line. Okay, and we already know slope tells us the amount that y changes, as x is changing. Okay? Okay, so let's take a look at an example where we're going to look at this set of data. So our first thing that we want to do is we want to go ahead and graph this data and make sure that we have some sort of linear equation. So we want to get a scatter plot of this data. So we're going to go down, we're going to label our x and y axes and figure out what we want to count by. So let's take a look at our x's. Our largest value on our x's is 34. So we'd probably be good counting by fives. And our largest value is 79, so we're probably going to need to count by tens on the y's. Okay, so when we finish numbering our graph and plot our points, we get a scatter plot that looks like this, and this is a pretty linear looking graph. We can see it's pretty easy to see that this line is trending up and to the right like this. So we can go ahead and we can look at how to create the table that goes along with our best fit line. So what we want to do is we want to go ahead and fill in our table exactly the same way we did in the last section. Fill in your x's, add them up. Fill in your y's, add them up, etc. So I want you to go ahead and pause, and I want you to fill in all the x values, add them up. Fill in the x squareds, okay, so that means square your x column, add up those answers. Square all the numbers in your y column, add up those answers. Multiply your x and your y column together to get these answers here, and then add up that column. So go ahead and pause the video and fill in those values. Okay, so if you take a look at compare your table, you filled in your values. This is what you should have. Again, the line at the bottom in blue are my sums for each of these columns, and I'm going to need those sums in order to be able to use my formula to come up with the best fit line. So the first thing that I'm going to do is I'm going to go ahead and I'm going to find my x bar and my y bar. Now remember, these are the means of the x's. So how do I find a mean? I add up all the x's and I divide by how many x's I have. So in this case, I've already added it up. There are 176 that adds up to, and there are 1, 2, 3, 4, 5, 6, 7 x values. Okay, so if I go ahead and divide that, I will get my x bar value, and then I have to do the same thing for my y's. So let's see, 176 divided by 7 is 25.14. And my y is 438 divided by 7, which is 62.57. 2 decimal places is fine. Okay, and now we're going to go ahead and use our formula to come up with our value for b. Okay, so if you need to, look back at the previous page so you can use the formula for b. Okay, our formula for b is n, which is 7, times the sum of the xy column, so that's 11337, minus the sum of the x column, so that's 176, times the sum of the y column, which is 438, divided by n, which is 7, times the sum of the x squared column, which is 4,628, minus the sum of the x column, which is 176, squared. Okay, so we're going to go ahead and put that in our calculator. And so if we put the top in our calculator, because I want to do this a little bit, let's see what that gives me, 2271. And if I put the bottom in my calculator, I get 1420. And again, 2 decimal places 2271 divided by 1420 is 1.60 to 2 decimal places. Okay, and then we have to figure out, again, this is our value for our slope, and we're going to use that to help us figure out the value for A, which is our y-intercept. Okay, and the formula for this is to take our y bar, which is 62.57, minus b, which we just figured out was 1.60, times our value for x bar, which was 25.14. So if we go ahead and punch that in our calculator, we get a value for A of 22.35. Okay, so we've gotten our B value, we've gotten our A value, but the question said, write the equation of the best fit line. If you don't write the equation once you have this information, you have not answered the question. I want the y equals equation for the best fit line. Okay, so the best fit equation is a special equation, and so y equals, we put a little hat on the y. Okay, y hat is, this means the best fit equation. It's not just any y equals equation, it is the absolute best y equation for this set of data. Okay, and all we have to do is write it with our A and B value. So y hat equals A, 22.35, plus B, 1.60, x. This is our best fit equation. It has to be written in this form if you want to receive credit. Okay, so the last thing that we want to do with this equation is I then need for you to graph this equation on your scatter plot. So normally what we do is we plot our y-intercept and then we count our slope. Well, counting this decimal slope is really difficult. So instead of doing that, what we're going to do is to draw our graph. We're always going to graph 2 points, and that is the y-intercept and the point x bar, y bar. Okay, so our y-intercept is 22.13, so I'm going to say that's around here. Okay, and my x bar, y bar point in this case is going to be 25.14, 62.57. So I'm going to graph that point, 25 and 62. If I had a ruler that I could use here on the computer, I would. You should use a ruler or the straight edge of your calculator or something, and you're just going to draw this straight line all the way across your paper. This is the line that best describes the trend of this data. And we're going to see how we can use that equation to predict values that we didn't collect in our data.